Lesson 52, interference from two-point sources. Yet again, I recommend you go to YouTube and watch some of these videos. There's a really cool one that we watch in Physics 30 also. It's called this, the original double slit experiment. Very important for Physics 20 and more important for Physics 30. So taking Physics 30, watch this video. You'll see it again in Physics 30, but you'll understand it better. And then there's another good video, wave interference beats. You can watch those two videos, and then you can come back to this. And I'm just going to explain interference from two-point sources as it pertains to Physics 30. Okay, so we've already talked about constructive interference and destructive interference. Now let's look at it. Let's say that we have a barrier, and that barrier has two slits in it. And then over here, we have a screen. And what we're going to do is we're going to send a water wave this way. It's going to be a big water wave this way. And it's going to hit this barrier. And then because it's a wave, it's just going to reflect. It's going to come back. However, when it gets to these two slits, it's not going to, it's going to go through the slits, but it is also going to diffract around the slits. So it won't go through the slits like this and then appear up there on the screen, right? That's not the way that water works. It's going to diffract. And diffract means to bend around. So when the water wave, here comes the water wave, it hits here and reflects. But here, it's going to bend. It's going to bend around that, and it's going to create these semicircles, right? And the same thing is going to happen over here. But now look what's going to happen. This is why this is called interference from two-point sources. The lines that I'm drawing, these semicircular blue lines, those are the crests. The trows are in between, right, which you can't see, obviously, but you've just got to imagine this three-dimensionally. So I'm drawing the crest. Now, what happens when this crest here, I'll do it in green, meets up with this crest here? They're going to produce constructive interference, aren't they? And they're going to create a super crest. So what's going to happen if we keep drawing these lines? And this one here. Okay, ooh, that's one of the better ones I've done. Every time these lines intersect, the crest from one wave intersects the crest from another wave, you are having complete constructive interference and you're creating a super crest. And I'll do those in red. Here they are. One there, one there. I guess there's one technically there. And what's going to happen? These super crests, if I keep drawing this, and I don't want to keep drawing it because then I always blow it and it looks so awful. And this is good up to this point. It's going to create a line and appear right here. It's going to, when it hits this screen, you are going to have all this constructive interference, and it's going to produce a it's what we call a central maxima. Central, oopsie, maxima, right in the middle, which is funny, isn't it? Because here's the slit and here's the slit, and then right in the middle there, you're going to get a central maximum. You're going to get a point where there's all this constructive interference. Now, if I keep extending that, let's go to black here. If I keep doing it with, so those are points of constructive interference. Well, here's another point of constructive interference, and there's going to be another one there, there's going to be another one there, and those are going to produce another point of constructive interference somewhere there. And then the same over here. You're going to have one here, and then there's going to be one here. If I kept drawing lines here, and then we go all the way to here. Oopsie. So you're going to have two other points on either side of the central maximum where you can have all this constructive interference, and what you get is called an interference pattern. What's in between here? Well, that is where a crest meets a trough and you get complete destructive interference. So the constructive, there, there, there. And in between those, you get complete destructive interference where a crest meets a trough. So on the screen, eventually, you're going to get sorry, that's a little messy, but what you've got in the middle, you've got n equals 1. N equals 1, n is the order number. Sorry, in the middle, n equals 0. And then on either side of that, you've got n equals 1, and then n equals 2, and n equals 3. And that's going to become really important when you take Physics 30, when you're doing Thomas Young's double slit experiment, that value. But the point is, in the middle, you've got a complete constructive interference. It's called the central maximum. It's always the brightest spot. Why is it the brightest spot? It's because at this point, the wave, when the wave comes out, diffracts around there, it's spreading itself out, and so it's losing energy because it has the same amount of energy, but it's spread over a greater area, right, because the wave is bigger. It loses the least amount of energy in the most direct path. So that's why this one's called the central maximum. It's usually the brightest line, and then they get progressively weaker because now the wave for this one here, it has to travel a greater distance, and therefore the wave is more spread out and it's less has less energy. So that's the basics of interference, diffraction, and interference patterns. And you can go through your notes here. It talks about the central maximum, constructive interference, minimal lines, the minimal lines and maximum lines. The maximum lines where you have complete constructive interference, the minimal lines where you have complete destructive interference, and so on and so on. And that's the basics of interference. And if you're taking Physics 30, this is a pretty darn important concept to get. All right, we'll see you for lesson 53, the Doppler effect.